So I know you've heard from a lot of different companies, a lot of different areas of the semiconductor industry. We hope this has given you kind of an overview of what the industry is all about, what chips are, how the industry comes together. One of the things that always amazes me about the industry is all the different sectors, all the different companies within the sector. They're all kind of intermeshed, you know, all the way from basic materials up through the tool manufacturers that build the systems that go into modern manufacturing, to the fab companies, and then at the other end, the companies actually producing maybe their own designs of chips or foundries for the outside world. You can be a chip designer. There's all kinds of things that go on. So hopefully this has given you an overview of what goes on in the industry and maybe gotten you thinking about it as a future career. Before I jump into this, though, let me just ask, how many of you are from outside of ECE? I'm an electrical and computer engineer. How many are from outside of ECE? Good. Have you heard something this semester that gets you interested, that makes you believe that there's life outside of ECE in this industry? Hopefully? Okay. So that's one of the important teachings, one of the important ideas. You know, people see this as an electronics industry and say, well, you have to be kind of an electrical engineer, electrical and computer engineer. But really the truth of the matter is companies come to us all the time and they say, look, we need people in mechanical engineering, chemical engineering, material science, industrial engineering, supply chain, business, statistics. So there's all kinds of things and all kinds of areas and jobs here. And as has probably been pointed out to you from much earlier in the semester, the industry needs people. I mean, there's a lot of stuff that's going on right now where numbers up to like 50,000 new employees over the next few years in the industry. And Purdue has taken this on as one of our goals, is to help educate and train the next generation of workforce. So as you're all aware, we have a semiconductor degree program, or degrees. I always forget to put the end of it. There's a number of degrees there. We started this actually only 2 years ago. We're about 2.5 years into the program. And it had the broad goal of trying to attract and train students for careers in the semiconductor industry, to cut across those various sectors you've heard about. And this meant disciplines across engineering and beyond. So we're trying to build off of some of our traditional strengths in research and our traditional strengths in how we educate students, and we do it at scale. As you're aware, Purdue's a fairly big place. But we set this up. And we have multiple pathways you can go down. I'll talk about some of these tonight. There's a semiconductor certificate that's kind of university-wide. You can take a set of courses or some courses from a list, but also do experiential learning like internship, study abroad. I believe this class actually counts toward it. We have departmental specializations in minors. We have specialized centers like SCALE, which is focused on Department of Defense related work. And there's a lot of informal participation. As you may have seen before, we have a leadership board of people from 40 companies. Matthew is over here, and he's the one that kind of keeps all this going. We have not only 40 companies, but the people on our board are people like CTOs, division directors, et cetera. So these are pretty well placed and pretty well connected people. We actually had a meeting with them most recently on Halloween in Washington, D.C., and showed them some of the things. Matter of fact, we showed them what was happening in this class. So they've all seen that, they understand it. And this is one of the signature things we talked to them about. So the very first question that was asked 2 years ago was, could we attract students into this area? If we wanted to educate and train the number of students, the number of people that the industry needs, could we first attract students? And so the very first thing we show them is changing the world with chips. And we say, look, there's been 512 students that have come through this class in the last 2.5 years. You're part of our numbers we show them. And this is intended to give you an overview of the industry, to let you understand what it's all about, but also for you to help map it back into your home disciplines you go into. There's also the STARS summer internship I'll talk about significantly more. This is kind of a pre-internship, and the real problem that we were trying to solve was the fact that this industry doesn't typically hire interns until after at least your sophomore year. So if we have this Changing the World with Chips course now and get everybody excited, and we say, oh, by the way, come back in a year and a half and maybe you can think about an internship, it's just kind of a long time to wait between it. So the STARS summer internship is highly competitive. Last year we got 750 applicants. We had about 98 slots. But I do encourage you, if you're interested in a summer internship next summer, to at least apply and see if you can get into it. But there's lots of opportunities beyond that also. So there's this whole pipeline of things that go on at Purdue that's part of our overall semiconductor portfolio. It really starts at the very left with things like K through 12. There's a lot of outreach activities to K through 12 students, high school semiconductor summer camps, things like that. In the middle is kind of our STEM education, and We don't talk about this too much on the outside, but Purdue has about 54,000 students now or something. 29,000 of you are actually in STEM fields: science, technology, engineering, and math. And sometimes we also talk about STEAM, including agriculture, because agriculture is getting more technology driven nowadays, but really 29,000 students in that field. We also incorporate Ivy Tech, which is our local community college network. They're developing programs including setting up a clean room, and they'll be soon having courses that do clean room fabrication. At the far right, we have things like certificates, concentrations, and minors. Most of you are in departments where you can access this. As a matter of fact, there's a university-wide certificate I mentioned before that you can all access, I think. And Changing the World with Chips is actually the first of the rings on here, so you've now been through the first ring. Anybody here are Lord of the Ring fans? Anybody like Lord of the Rings? Okay, there's one ring, right? First ring. Not the ring to rule them all, but at least there's rings here, so you should be able to relate to this, right? In between there's actually over 100 semiconductor-related courses. So almost all of you will take at least one of those semiconductor-related courses as you move forward. Most of you will take multiple of those. So even if you don't declare yourself a semiconductor person, you will almost certainly wind up taking some of those courses, okay? And then the other things that are on here that we really focus a lot on and highlight are really experiential learning programs. Things like STARS, the Vertically Integrated Projects programs, study abroad opportunities, the internships and co-ops with companies. These are all experiential learning, and I highly encourage you to get involved with these. This is what industry comes to us and says, we want people that have done extended projects. We want people that have hands-on experience in doing things. We want people that have worked as teams and show they can do it effectively, or people who've had international experiences and know how to deal in this international global industry we have. I've almost never talked to a person from industry that says, tell me who's had the most classes. Or they can look at your transcript and understand your GPA, but they really want to know what you've done to build those skills, how you communicate, how you interact with people, how you run a project, how you understand some things that are relevant to the industry. So this is where it happens. It's really your coursework plus your experiential education experiences. Any questions? Anybody have anything they'd like to ask or talk about, or big unknowns? Yes? What happens in the STARS program? I did not pay them, but this is our first lead-in to experiential learning. So the STARS program, see, isn't it beautiful how these things come together sometimes? So STARS program is a 8-week summer program. It's a paid internship. We get money from companies, sponsorship from companies that actually help us pay that stipend to the students to be on campus, so at least covers your living costs and all that kind of stuff. And it's aimed at rising sophomores, so people between their first and second years at the university. It helps bridge that gap until you're ready for a company internship, or until companies are ready to hire you on an internship later on. In the last couple summers, we've actually, and by the way, it's a very hands-on program. The picture in the middle is actually one of our students from last year in the manufacturing track, which I co-led. She's actually in the clean room. She's got a bunny suit on in the clean room. She's looking at two wafers. They're actually kind of upside down, but they're suspended in this evaporator system. So the students actually got in and did hands-on processing in equipment that we have over in the Burke Nano Center. The other two things that are illustrated here are chip design. We have a chip design track and then an advanced packaging track. So the design track is set up so that you can actually design your own integrated circuit. So during the course of the 8 weeks in the summer, students actually do a chip design. You see some of them here, some of the projects. They're things like music synthesizers and guitar villain. I don't know exactly what a guitar villain is. Some of them did like video games, snake games, and things like that. So you actually did your own chip design, and during the course of the summer, they implemented it on what's called a field programmable gate array, which is basically a circuit board you can buy. And then after the program was over, these were actually fabricated in external foundry. So these went out and were fabricated. Chips were fabricated in external foundry and came back for testing later on this spring, actually. So you can actually design your own integrated circuit. The manufacturing and packaging tracks kind of work together. As I mentioned, the students got in the clean room. These are bunny suits, in case nobody's mentioned bunny suits so far, but the head-to-toe suit is to prevent you from contaminating with dust and stuff the environment in the clean room. The wafers you see in the middle, there's two of the students pictured there. And the advanced packaging track actually made a souvenir printed circuit board. This is a copper traces on a insulating board, and the thing in the middle is actually the chip, the silicon chip that our manufacturing track students designed. So by week 4 of the program, each team had designed a block of that test chip, and then we had the mask made. The students then spent the rest of the summer fabricating using their own mask design. Okay? So this actually was featured on NBC News. We had a video crew and a producer and a, what's the on-air personality called? A anchor came and did a video on it. We can post a link to that. You can see what they actually talked about. But during the course of the summer, the students learned presentation skills. We had joint Friday lunches with team presentations. We had a pitch competition where students could pitch what they were doing. There were a couple of follow-on trips. Some of the students were selected to go to a conference, Semiconductor West out in California. Another group went to Global Foundries, which is one of the major fab facilities in the US. And we got media coverage on NBC News Video, Indiana Business Journal, and a print story from NBC News. These are the student representatives that actually went on the Semiconductor West trip. These are the students that went to Global Foundries, including gowning up and going into bunny suits there. So the experience we had here put them in good standing to be there for the bunny suits. And so there were some productive things the students were able to do. Oh, wait, I want to loop ahead a little bit. I want to tell you a story before we go too far. We'll come back to some of this. Okay, so I want to tell you 2 case studies, both related to stars. So the first one actually relates to this NBC News video. So we had, I guess the second one first. So we had a student in the 2023 STARS program who was on the design team. They were the ones that had designed their own chip, had it fabricated and stuff like that. At this point, by 2024, we'd been working on NBC News, we meaning a PR firm working with the Indiana Economic Development Council, been working on NBC News for 2 years to get them to come do a feature on our programs at Purdue. And you know, some of our faculty colleagues had talked to them, other people had talked to them, and they weren't sure they wanted to come. Then there was a phone interview that involved 2 of the students that had been in STARS in 2023, one of whom was one of our young women who'd done the chip design. She was scheduled to do a 2024 interview at NVIDIA, and when they found out, she was very impressive on the phone and everything, and suddenly NBC News decided, hey, we should come to Purdue because of this person. So she impressed. One of our STAR students impressed them, NBC News, enough to send this whole film crew out. Now the ironic part was by the time they got here for the filming, she was already off at NVIDIA, so she wasn't available to actually appear in the video. But it was a STAR student that actually convinced them to come. After 2 years of PR firms and Purdue faculty and everything talked to him, it was one of the STAR students that actually sealed the deal. The other story is we had a student who was on our Burke VIP team. I haven't talked about VIP team yet, but we have a long-term project team in Burke. She'd been working on it for 2 years. She came in with no prior knowledge. Her team worked on this, and then she served as a Burke summer intern. They generated actually a set of 24 wafers. The histogram here is actually a Gaussian curve that came out from looking at the thickness distribution of a deposited film over 24 wafers. She wound up being a consultant for one of our master's program teams. She was an undergrad, but she wound up being a consultant for a master's program team in ECE. She went off and was hired by TSMC in Arizona, who said she had exactly the skills we need, and now they sent her back to campus to recruit more students coming out of our program. So our student who'd gone off through this VIP program impressed TSMC enough that now investing both in more students to be hired, but also they're helping to pay lab costs to keep that program going in Burke. So if you think about yourself who's going to have as a person who's going to have an impact in the world, these are the ways to do it, right? You don't have to wait until you're out and working in industry for a dozen years or so. You can do it now as one of our students and pushing things forward. Okay, let me go back and get on track here again. Okay, so let me just first of all say, as I said, STARS is very competitive, but there's lots of other ways you can participate. be in these experiential learning programs, take courses, et cetera. So there's a lot of things going on, including, we're at the bottom I want to focus you on here. We have some things going on where we're trying to develop kind of academic year exercises related to STARS, so you could come in and take courses for course credit during your normal academic year. So even if you aren't available in the summer, there'll be experiences available. We're spooling up new manufacturing and packaging lab spaces so we can have undergraduate labs that cover these areas. For those of you who are hands-on, like to do things other than just sit in a classroom and work on a homework assignment, I think we have lots of things going on there. And we'll be developing new course modules as we go along. As I mentioned, we have over 100 semiconductor-related courses. They're in things like engineering across lots of disciplines. They're in supply chain. And as I said before, almost all of you will take at least one of these during your time here. There's a university-wide certificate that involves things like experiential learning plus some of these courses. And there's department concentrations in minors. The ones I know about we have spooled up are in ECE and ME, but I think there's ones in the works in industrial engineering, MSc, and chemical engineering. So for those of you going into any of those disciplines, they will be available. And there are company internships. There's lots of companies that are interested in hiring students to come in as interns in this field. The disciplines will vary by sector. As you've heard this semester, different sectors of the industry are interested in different types of engineering, generally starting after the sophomore year, and we certainly have great resources through our Office of Professional Practice. The Scale Center has its own independent sort of internship office, so there's great resources to link you up. We are, I believe, going to have, where's Sophie? We believe I'm going to have a semiconductor-specific career fair in the spring. So those of you who've seen things like Industrial Roundtable, which is the big whole campus career fair in the fall, we're going to try to do one spring or next fall, I guess, maybe next fall, that's semiconductor specific. So it will likely be a dedicated career fair just for semiconductor area by next year. There's also international experiences. I don't quite count Silicon Valley as international, but there's also a Silicon Valley trip. So study abroad experiences, there's lots of international partnerships. Purdue has signed strategic agreements with a number of countries, so you will start seeing those more and more as you move forward in your program. Let me talk about a couple of special programs, special opportunities that you can get involved with over multiple semesters and in multiple ways. The first is called Vertically Integrated Projects. Are any of you already on a VIP team, by the way? There are some freshman teams on that, or first-year teams. So Vertically Integrated Projects is a program headquartered and created at Purdue. It's currently over 50 universities across 16 U.S. states and 14 countries. And worldwide, there's 4,500 people working on this. What they really are is multi-semester team projects. So you can join a project that will be going on over the course of several years. You can be on it personally for several semesters, and it can also be used as your senior design course by the time you get there. So we have two of these going on right now that are semiconductor focused. One is the SOCKET team. SOCKET stands for System on Chip Extension Technologies. It's a chip design. So if you want to be a chip designer, it's a great way to get involved with that and practice it. They try to make it as similar to industry practice as possible, which includes periodic tape-outs at an academic foundry. So your chip design will actually be fabricated in an external foundry periodically. It's now grown to almost 200 students, including a group on the Indianapolis campus now. So this is a big program where you can actually do kind of real-world chip design. And Professor Swaby, who you know from this class, is one of the people involved with that. So it'd be a great opportunity to follow on if you want to go down that pathway. The other key VIP team is actually in our Burke Nano Center, and if anybody's not been through the Burke Nano Center, it's still, I think, the most advanced technical building on campus, even though it's approaching its 20th anniversary. But it's also undergoing a $50 million renovation to allow us to upgrade to 8-inch tools, which are 200 millimeter for the semiconductor specialists in the field. And that will allow us to partner much more closely with industry. So we have this initial program that's on statistical process control and advanced packaging and heterogeneous integration. It's now about 35 students per semester, but they do have additional space opening up. They're increasing capacity. There was kind of a debrief meeting with this semester's cohort yesterday over in Burke that I attended, and I asked them, what should I tell this group? I told them I'm going to be giving this lecture today. What should I tell this group? And they said, you absolutely should do this. This is a great experience. It's really useful to learn about things, to have hands-on. There's senior students that can mentor you as you get started. They're very interested in expanding out that pipeline. It's kind of senior heavy right now, but they're very interested over the next year or so bringing in more. And I think they generally want you to be sophomores when you start. Some of you may be sophomores by next semester, but certainly by next fall, this would be a great opportunity to look at. And again, they're trying to expand the capacity so you can get involved there. There's a few examples here at the bottom. There's a wafer. They're actually processing their own wafer. You've learned a lot, I'm sure, about wafers this semester. On the right is actually a advanced packaging design. This happens to be an aluminum nitride-based substrate. And they're moving forward on all these fronts. Okay? So great hands-on opportunity to be involved. The other broad center I'd like to talk about is called SCALE. It's actually a workforce development center that's focused on Department of Defense. It's co-directed by Professors Bermel and Douglas in electrical and computer engineering and engineering education, respectively. And SCALE is actually a multi-university network that spans coast to coast. They actually have a really nice graphic showing who's going to school in various regions of the country, where they're going to work for internships, and where they're then going on to their final jobs and things like that. It's a great network. They actually have a number of kind of vertical themes. And again, because this is related to the Department of Defense, there's some things you might expect. There's things like trusted systems, embedded in trusted systems, so you can have security. There are things like radiation hardening, commercial leap ahead. The military always talks about things that are related to both military applications, but also dual use in industry. And certainly somewhat focused on U.S. citizens. So if you happen to be a U.S. citizen and want to get involved in a broad program, this is a great opportunity. They have sort of customized mentoring. They have lots of internship experiences and joint courses and curricula that go across those institutions. So we're now 2 years, as I mentioned, into Purdue's Semiconductor degree program. And these are some statistics we presented to our leadership board a few weeks ago. We've had a 7 times growth in experiential learning programs. We're currently about 280 students in those programs like STARS and VIP and study abroad and things like that, SCALE. And you present this number to the semiconductor industry, and they're impressed by 7 times growth. So you've heard this semester about how Moore's Law works and how exponential growth has been going on in the industry. So if you can impress people with this industry by how fast you've grown, you must really be doing something, right? But they were all kind of impressed by this. As I mentioned, 512 students have taken this class. We've had over 2 summers, 174 students in our STARS summer internship. We have over 500 students that are currently signed up for one of those certificates or department concentrations or the SCALE program that I mentioned. Over 2,900 students at Purdue take at least one of those semiconductor courses each semester. So that's why I was pretty confident most of you would wind up taking some of those, because there's almost 3,000 of your colleagues that are taking one of those courses. And for those of you, I don't know if anybody attended, many come to this event we had the night before Roundtable back in mid-September. SK Hynix was talking. There were 600 people in the room. It was required? Oh, you guys were required. Was everybody not there? I'm going to rat you out. Okay, so there were 600 people in the room. I was sitting in the back, and I couldn't even see the speaker, right? Because there were so many people in that room. But I think it just shows you the interest. For those of you who are there, there's lots and lots of people on campus that are interested in this field. They're working on it. I think it's a great program. But let me leave you with kind of one last thought. In my mind, what I've learned, I've only been in this co-chair position of the Semiconductor degree program for about 3 months now. But the thing that I've really learned from looking at all this is there's this real ecosystem that's developing, right? You've heard this semester about the semiconductor ecosystem, how there's tool manufacturers and foundries and chip design companies and material suppliers, and they all kind of work together in this big ecosystem. But what's happening at Purdue is we're really developing this student ecosystem in semiconductors. So we have these multi-semester experiential learning programs I've talked about, but what's happening is within those programs, if you're in a VIP team or doing an individual undergraduate research project, whatever it is, you're applying course knowledge, you're developing ideas beyond your textbook topics, you're learning problem solving, which is really important to the industry also. And then experienced students start becoming leaders on the teams. They help train new students, they're defining the projects, they're defining the process flows, things like that. The experienced students also become peer mentors for STARS. So if you're in a VIP team during the regular semester, then we hired a number of them last summer to be the undergrad TAs or peer mentors for the STARS program. They work as summer interns at Berkeley or other places on campus. Students then go off to corporate internships, and everybody tells me that when students come back from corporate internships, they're really high value added to their teams. If they come back and rejoin a VIP team or work on another project, everybody views that they've gained a lot. They really have got these insights from industry. They're really high contributors to that. Graduate students are serving as project mentors and TAs for things like the VIP course, the STARS course, some of our other courses. And I happen to also co-direct the ECE Professional Master's Program, our Project Track Master's Program. And there for the last 2 years, we've had Master's Program teams working on new developments for things like the STARS program. So there's this real cross-fertilization and ecosystem that's evolving. And I think you should all feel really fortunate because we spent 2 years getting this spooled up. If I would have given this talk 2 years ago, I would have said, well, we could maybe finally get some people through it. But now we really have all this working, right? You'll benefit from the fact that now there's people that have done this for a couple of years ahead of you. You get involved in these VIP teams. There'll be people who have spent 2 years getting the team up and running and know what's going on. They can explain to you what's going on, get you involved pretty quickly, give you the right tutorial material, the right advice to move forward. So I think you're in a great spot to kind of add on to that ecosystem and really move things forward. And I already talked about students as ambassadors. Let me also point out that we now have a Semiconductor Student Alliance. Did anybody go to this conference a couple weeks ago? They had the November 2nd conference. We have a few people who went. So, we have the Semiconductor Student Alliance that's organizing the events. It was called Students for Chips. They have a job posting list. I think they'll be really involved. So if you want to join another student organization, I think it's a great thing to get involved with. And as I said, there's this real, I think, enthusiasm, ecosystem, external visibility. Lots of people around the country now know of Purdue as the place for semiconductors, and I think it'll be a great thing to build off of. So my advice to you is stay involved. So find something to get involved with. 4 years from now, if you say, well, I went to a lot of classes at Purdue, it was kind of fun, I enjoyed slogging through the slush and snow occasionally, you will have missed the experience. I think get involved in these things, whether it's going for the certificate or concentration, whether it's just taking some courses and enjoying them as you go through. Experiential learning and programs, internships. As I said, we have a good infrastructure to help you connect to those companies. The companies come to campus, they're recruiting Purdue students. The Purdue name means an awful lot out there. I mean, as I travel, as I interact with companies, I just say I'm from Purdue, and suddenly I have a level of respect and attention that I would not have if I was at a lot of other places. There's individual research projects and other opportunities to get involved with. I mentioned study abroad, these international partnerships, and then the Semiconductor Student Alliance. So find some way to get engaged. College is about classes, yes. You need a good GPA, yes. But what will set you apart is the ability, and will help you develop, not just look good on your resume, but will help you build those skills you need to be really successful in your career, right? You're all thinking right now probably about where do I get that first job, or maybe if I'm going to go to grad school, where do I get into a good grad school? But the real thing you should be thinking about is what sets me apart 5, 10, 15 years from now, right? Once I'm in my job, okay, there's 500 people hired by my company this year. We're all going to be sitting in offices or cubicles someplace. How am I going to contribute to my company, be recognized by my company, get promoted, get a raise, move up? And these are the kinds of things that let you do it. Your ability to connect to people, your strong technical background, connect to people, express your ideas, work in a team, be ready to lead a team. This is how the world works, okay? So thank you for your attention. I'd be happy to answer questions or take comments, and then we'll turn it back over to the people that actually know what they're doing.
Do you have any questions about the programs that we just talked about?
Yeah.
I know you talked about a lot of STAR students generated from this program. I'm curious if any of them are international students. So do they still have a decent success in terms of internships and industry, because it gets to a different landscape for hiring those students? Does STARS give them an advantage?
Well, I think STARS is, definitely has some visibility. I think it gets people prepared. There'll be companies looking at it. There's always visa issues related with internships and stuff, but those can all be navigated. So I think it's good visibility. I think it's a good thing to do. But equally important, I think, are these other things. STARS is one thing, but VIP teams and individual research programs and things like that are what will kind of set you apart. Right? Okay. And make sure to do well in your classes too. I'm not telling you not to do well in your classes. That's really important, right? I am a professor. I can't tell you to do poorly in your classes. What else do we have? There must be some other things people are thinking about. Hey, by the way, it's cold outside, so if we adjourn early, you got to go outside earlier. So we could keep talking about it. It's warm in here, right? Okay. Yeah, go ahead.
For the scale program, is it for, you said how the STARS is for sophomores, internally sophomores. Is the scale program also like for sophomores, or is it for more later, like graduate students?
You can join Scale as a sophomore. Maybe you can join them next semester. I don't know. They have call-outs once or twice a year, I think. But you can join early. It's not for just a senior master's or anything. You can join Scale and then be involved with it over multiple semesters. So I think what they want people to do is get engaged fairly early on. Sign on as a sophomore, do it for sophomore, junior, senior. You can also do it as a master's student, by the way. It's available there. And I think the real intent is to have you involved over multiple semesters. They have their own vertical projects and things like that. As a matter of fact, within VIP, the heterogeneous integration team is kind of affiliated with Scale. So I think they have a lot of things set up with the assumption you'll get in as a sophomore and then work your way on up. Thank you.
What does the timeline look like for applying to the STARS program?
Soon. I think we're opening the website, maybe open already, December 1st? December 1st. Apply early, apply often. Well, you don't have to apply often, you apply once, but apply early, sure.
For the STARS program, so are other schools allowed to apply to the STARS program, and if so, what's the preference? Is there no preference? What university, or do Purdue students get preference, or?
That's a great question. So last year, as I mentioned, we had 750 applicants for STARS. 200 of those were from outside of Purdue, and we never advertised it. It was supposed to be a Purdue program, an internal to Purdue program, but we got 200 applications from outside of Purdue. The students involved were mostly from Purdue. We had 5 students from Ivy Tech, that's one of our partners in the program, and then we had kind of onesie twosies from several other places. But it was really intended to be an internal Purdue program. So its preference is strongly for Purdue students. Can I say preference is also for people who've been through changing the world with chips? Okay, preference is also for students who've been through changing the world with chips. So this, make sure and indicate you've been through this class on your application. Okay. Yeah.
And then as a follow-up question, what kind of things are on the application for that? Or is it going to be mostly what classes you've taken or stuff like that?
Yeah, the application is, you'll fill in we look at several things, but you'll fill in some simple stuff like when you started college, when your expected graduation date is, because we really want this to be an early program, not after your junior year or something like that. What your major or intended major is, some brief statements about your area of interest. There'll be some of these tracks I mentioned, design or manufacturing will ask you to indicate that. GPA information, things like that. But nothing. You don't have to write an essay. You don't have to write a college essay or anything. You've already written enough college essays, I'm sure. Or maybe just append your college essay. You reuse that. Since I'm sure all worked on that real hard, right? You have to write an essay to get in Purdue, by the way? You must have to write something, right? Okay, yeah. Okay. What else do we got? There must be other things in people's minds. Yeah, there's one back here.
If I have an interest in chip design in my career in the future, and if I'm a freshman right now, if I get an internship this summer, if I get an offer, do you think it would be more helpful to do STARS or do the internship?
I think if you get an outside internship offer, take it. I mean, we created STARS with the idea that a lot of companies didn't want to hire interns until after at least the sophomore year, so we had to have something for them to do. But if you can get an internship this summer, I would say grab it. That's a great experience.
And do you think it would be worth it still to take STARS next year, or do you think it's better to take?
Well, actually, no. If you already got an internship, then you don't really need STARS, right? It's really intended to get students kind of up to speed on some simple ideas and things like that. But by the time you've gone off and done an internship in industry, you will probably have gotten most, and plus taking classes, you'll be taking extra year classes. So you've probably gotten most things. Matter of fact, for STARS this summer, one of the reasons we ask about your intended graduation date and things like that is we had students applying who had already been through 2 full years of, say, ECE courses, and we turned them down for STARS. We figured they already got all they need. They can go to and get an internship. And some squawked at us like, wait a minute, I've had this course and this course and this course. And we're like, well, exactly, so you don't need STARS. You've already had all the things we would have taught you in STARS, right? So I would say between your coursework you're taking and if you have an internship, you'll have already done everything that we really were trying to accomplish in STARS.
All right, thank
Okay.
you.
But, let me just say STARS specifically. We realize most of you are taking classes right now or maybe from your advanced placement or whatever where you know something about chemistry, you know something about physics, but you really haven't gone deep into your engineering discipline yet. A few of you probably taking maybe your 201 course or something like that maybe. Anybody taking a 201 course in their discipline already? Maybe next semester? 201 next semester, 2K1 in ECE. I'm old school, I still call it 201. Okay, so by next semester, a lot of you will have taken that kind of, first course, thermo in ME or, or 2K1 in ECE or something like that. But, we understand you're not integrated circuit or processing people yet. You haven't seen all those things. So we start STARS with that basic idea of assuming you understand some chemistry and physics and things like that. But then, as I said, once you've had a year or two of coursework, once you've been through, say, your sophomore year, then you will have had courses where now you're actually starting to learn something about your home disciplines. You understand the basics. You'll all take a fundamentals course, a thermodynamics and basic mechanics or some basic materials courses or in ECE, some basic circuit courses and stuff. And so you'll already seen that. You're already developing that skill set. So that you're already ready to go. You go get a job in industry, go get an internship in industry, and you'll be well served. Okay, I should wrap up because you guys have some more things to talk about. So.
Yeah, I just need 5 minutes. So.
Okay. Well, more questions then if you want. So anybody else have any more questions? Okay, if not, let me thank you for your attention. Point out that we've got a lot of information on the Semiconductors website. So if you search Semiconductors at Purdue, you'll find a lot of information on things like the certificate, the list of courses. Some of these other opportunities are linked there, so that's a great way to stay involved. The Semiconductor Student Organization, I think, would be a great thing to get involved with. I think they'll have a lot of energy. They'll be doing a lot of things, so I encourage you to connect there. Companies come to campus all the time. Matthew brings companies on a almost daily basis. One spoiler, I guess, or teaser. We will have the CEO of a major semiconductor company here in January. There'll be a presidential lecture. So, we've got a CEO of one of these big companies you've heard about coming mid-January. And, presidential lectures are a big thing. It'll be the Purdue's president hosting this distinguished external visitor who will almost certainly bring along a delegation of other people. So pay attention to announcements. That'll be a great opportunity, I think, for you to hear from the very top of some of these things. You've heard some really top-notch people here this semester, and so I think that would be building off of that. So pay attention. Those things are coming up. These companies come to campus. They want to talk to students. So they need you as much as you need them. You may be sitting there thinking right now, man, how do I get that first job? How do I get out there? If I go to school for 4 years, will I be able to go to work? They need people, okay? And they will be interested in engaging with you, especially once they know you're interested in this field, you have some background, you're building up some coursework, some project experience, internships, whatever it is, they will want to talk to you, okay? So don't be shy about this. They need you as much as you need them, okay? So pay attention to that. Get out there, introduce yourself, Volunteer to be a student host when these companies come to campus. These are great things to do to connect, okay? Do we have a student host program?
Not formally, we can talk about it.
We should start a student host program. All right. You got invented right here. We're going to go patent that, so it's all good, right? Okay. Thank you very much for your attention. Enjoy the rest of your semester.